So this presentation doesn't have slides. It has this guy. So you see my entire talk here, and I just have to make sure that the buttons is working. It doesn't appear to be, so I'll use this one. Oh, it's not in focus. So yeah, today I want to talk about like scaling education with JupyterHub, nbgrader, and JupyterQuiz. So just to start off, who of you has ever taken a programming course at like university or something? Raise your hand. Pretty much all of you. Who of you has taught a programming course? Still a few guys. Okay, so you want to teach a course on some matter, whatever it is. So you have to think about what you want to do. So you ideally you will have some story to tell, right? You have something, you're motivated, you want to teach people something. And then you say, okay, I need to fill my course somehow. I need some components. Maybe it's even mandated. So maybe at the end, I want my students to do some kind of capstone project. Maybe I need some exercises to really enable students to learn the material on their own and to really not just listen and watch, but also to do stuff themselves. You might have a lecture. This is typical for university courses, that you transport the knowledge in some way. You may even have exams at the end. This is also mandated, right? So you're excited. You want to do these things. You want to do it in the way you want to do it, right? Because we all have our teaching philosophy, how we want to transport these things. But then there's this thing, right? So you teach at a university. You have some requirements which are put onto you from the outside, which you have no control over. For example, you may have to administer some tests, some exams, for example. You may have to give grades to students in the end, right? So, of course, you can do this just everything by hand. You can hand out grades however you want, hopefully. But you also may need to use some kind of learn management system which a university provides for you, right? And then the university also says to you, okay, you would like to offer this course to 100 students. And next year they come to you and say, all right, we have 2 new study courses. I'd like to offer this course to 200 students. And then it's 500, and then at some point it's just not doable anymore. Especially when you do things like teach programming, like basic Python. You might have a huge audience at some point. So at this point, you're a little bit angry because you want to teach people, right? You want to transport your knowledge in whatever way you want. You don't want to be bogged down by these institutional requirements, but you want to enable students to learn. And then you think about, where do we run Python? Like, on which device do you want to run all of the code? Because you will have to write some code and execute it on some level. The Python has to be run. So you start out and you think, okay, let's do a local installation. You just provide an environment file and every student installs Python for themselves. This is a skill. You want to teach this to students at some point, right? So you can't just teach programming, you want to teach them also how to set up the environment. When you've done this, the students have access offline and they have the control over everything. But imagine you teach a course with like 200 students, 5% of them have some kind of difficulty with their setup, then suddenly you have like at least 10 students who need extensive debugging. And in practice, it's not 5%, it's more like 20% or something, especially if you deal with freshmen and like different operating systems. And you might end up with like having some students fix some like clever workarounds, and then at some point later in the course, everything breaks, and they are unable to complete your course. And then you get angry because you want to teach your students. You want them to learn. You don't want them to struggle with a local installation, especially for the freshmen. So, next approach, JupyterHub. Great piece of software. You can just run it anywhere, so you can self-host it. So you set up your own little server with the JupyterHub installation, and in the end, you will not be the only lecturer. Everyone will maybe teach something. And then you run into problems. I hope that this, no, hold on. Yeah. The problems you end up with is scalability and security. You don't have the hardware to set up your own JupyterHub on your office machine and run 200 students. And also security is an issue. Like, you don't want to necessarily take care of all of that by yourself. You might make some kind of mistake. You might run into some bottlenecks. You might misconfigure something, and then you have a problem. So at this point, you want to give up. You just can't handle it. You can't do local installations because you will run into problems. You can't host it yourself. So what you need is some kind of JupyterHub as a service. And this is a service for a university. It's university-wide. You can set it up. Because you are not the only one with this problem. Other people will want to teach something as well. So this is how you can set it up. So you, as a teacher, you want some kind of JupyterHub. So you request it. And then you need some sort of governance to say, yeah, you can have some university resources to teach your course. This is how it should be. Right? The university says, teach this course. You should be able to teach the course. So then they approve it. And next, you have your students. You can either invite them, or they can apply for participation. Via the Learn Management System, you just set up a link. And then, yeah, within this application time frame, you can then say, okay, at some point, all my students should be aboard. And then, basically, you can deploy your JupyterHub. Because it runs, so to say, in the cloud, ideally your own, the person who set this up can be pretty sure that you don't have issues with security if they do it correctly, and it's also scalable if you get the hardware. And then you can use this. You can deploy your course material. The students can use this. Problem solved. When it's all done and the course is finished, the students can download the course materials, and you can just delete it and serve the next iteration the next year. So here's how this looks in practice. Hold on. I want this. This. Yeah. So you need some security. So you can set this up with a two-factor authentication, which you really should do, because you have no idea who else might try to access this account. Students will lose their access at some point, and well, that's a problem because you allow them to run any kind of code on this machine. So you need to have two-factor authentication set up. You can then, basically, hold on. This is a little bit too fast for my liking. Yeah, with this portal, you can then request like a usage period from when to when do I need this, what kind of notebook do I want. You can provide your own containers, basically. Like depending on which packages you want to deploy. You can also set up resources. So you can say, okay, I expect 25 users. I need maybe a quarter of a gigabyte of RAM per user and a quarter of a CPU core. And I need some storage, also in gigabytes, for example. And well, this is what, if you didn't have this, you would have to set it up all on yourself, by yourself, right? But if you have it set up, yeah, you can submit such a request, and ideally the university, the government, will approve this request, unless you request too many resources. And then, okay, your request is accepted, and you can manage participations. You can invite students, you can send an invite link, and send it to the students. The students will get this link, they can request access, and they will also have to set up an account with two-factor authentication, of course. Otherwise, you know, you run into security issues again. And then you as a teacher, you can reject or accept the participation request. You can say, okay, this student clearly doesn't belong to the university. They don't have a university email address. You can deny it, or you can accept it. And then at some point, you start the course. So you as a student can then basically open it up. And these machines, these containers, they will spin up and spin down as needed. So if you don't access it, it's down. If you need it, it will spin up within a few seconds. And then you have something like this. This is just a Jupyter Lab interface, right? Excellent. So you have this set up. If you're interested in this code, this is actually not my work. This is some colleagues of mine who set all of this up. So if you're interested in deploying your own JupyterHub as a service, you can just use this software. Okay, but then now let's get back to your institutional requirements, because you have not solved the problem, right? We have not solved the problem. We have just deployed an environment where students can run Python. You still have some course components you want to deploy. And for that, we can use a nifty tool called nbgrader. So you have your Jupyter notebooks, and you just want some infrastructure to deploy these. And you have some assignment lifecycle. So for all your course components, for your lectures, of course, you create them, and then you want to hold them some point. You want the students to take notes, and the same for lectures. You want to create them. For example, you have like a script as a Jupyter notebook with some gaps. So you can present it and the students can fill it out, because we all know that writing stuff yourself is much better for learning than just watching a lecture video. And then you present this and students take notes. The next point is that the nbgrader is a really powerful thing. I encourage you to look it up yourself. This is from guys in the US. And you can, I will now show you what it looks like in practice. I hope it's big enough. So hold on. The first thing I wanted to show you actually is like, it's not in here, but hold on, reduce the size a little bit. So this is actually the same container you will have here, and this is basically the life cycle management. So you can create your course materials, then you can generate them. You will get some outputs. Now, of course, you can preview what you just created. It has also functionalities for like releasing assignments and collecting them. You can write plugins for this. And yeah, so you have some source, and then you have the release stuff. And now the first thing I want to show you is the integration of Jupyter quizzes, which is, you can use it in a lecture just as an interactive component. In the source, you might have something like this, just markdown for, I have an ungraded quiz, for example. There's a single choice, this and that as options. And then this is converted to JSON, so the students don't see the source code. They don't see which answer is the correct one. And then they can choose the answers. It appears that for some reason the stuff was bonked, so I will have some additional work to do on the plugin, it seems. Anyways, let me switch back. Hold on. This is something which works over here. Yeah, so you can do this. You also may want to set some exercises, right? You want to create some exercises and you want to release them to students. The students then can complete them, then can use this JupyterHub to work on the exercises and submit them back to you. You might also have to use the learn management system if your university claims that you have to upload it to there and you have to download it again for it to count in some way. And then you grade it and you feedback. So the nbgrader is a pretty powerful tool. It can do all of these things out of the box. create an exercise and has some built-in tests. But we have heard earlier today that PyTest is nice. So this is the next part which I want to show you is PyTest integration. So I have an example here. I want to show you this very simple example. So you get a lower bound and you get an upper bound of an interval, and you get a divisor. And the question is how many numbers in the interval are divisible by the divisor, and students are supposed to write the solution here. You have to specify, of course, that this is an example, and the code should work with every numbers you give them. Which in this case, the answer would be 2, I hope, because like 7 is divisible by 7, and 14 is divisible by 7. So this is the output they should get, and of course here directly in the source notebook you can write your solution. Right? You say this is the solution to my exercise. Of course, you can do this any number of ways. You can do it more Pythonic, less Pythonic. You can take account of like special cases. You can handle weird inputs where someone decides to hand you a float, whatever. And then basically you submit this to PyTest. So hold on, So afterwards, of course, for these inputs, we should in the end have the number of divisibles being equal to 0. So you can import PyTest, and you can submit this cell directly to PyTest. Again, you need a module plugin for that. And this is something you would normally not be able to do, right? Normally you would just write Python modules and then you test the modules with PyTest. But in this case, you submit this, whatever the contents of the cell is, you can submit that with a plugin, and then the code gets executed by PyTest to see if that holds. Of course, you can not only submit code cells, you could also submit classes, or you could submit functions. And then you can run your test cases. For example, you have them as a YAML file, where you specify, okay, for this input, I expect this output, and you can produce any number of test cases you want, so they are like not transparent to student, in case you don't want to give the solution away because your tests already contain the solution. And then you run PyTest. Oh, hold on. I forgot to generate the test cases. So you might generate some test cases where you say, okay, if I have this input, I get this output, and then you can write them in a YAML file. Forgot to create that beforehand. But once you have done that, you may, of course, need to restart your kernel. Then you can submit it to PyTest. Of course, you would submit the YAML file to the students. And then it still doesn't work for some reason. Hold on. Oh, it complains that it's not a file. Always good to test your stuff beforehand, right? You should give the proper path. A tiny bug in there. Number of divisibles. And then, yeah, you can run your tests and you find out that you made a mistake. Hold on. I'm sorry. I promise you I got this to work. I might have just like reset the storage. But you could also write a PyTest file. Hold on. Yeah, I think I know what's going on. I reset the Docker container in which this is working, and for some reason, some of the files got wrong. Anyways, let's return to the presentation. So you can do this. And ideally, the test cases are transparent enough that the students will see that for these and these inputs, I will need those outputs. You can test directly from the notebook. You don't have to run PyTest on a command line or with a module file. And yeah, you can also use these files. You can just run them on the submitted notebooks and get automated assessment. What you also will need is some kind of integration, ideally with the JupyterHub service you requested, so you can more easily transfer the files. But this also depends on your learn management system. What about other languages? The nice thing is that with PyTest, you can have PyTest CPP, for example, and we have already set this up. So you run PyTest CPP from your notebooks. This also works. You just need the appropriate PyTest plugins. Yeah, so yeah, this is it. It's a little bit haphazard, and but I hope I could at least demonstrate like some of the basic ideas for like how this should work in practice. Thank you.
Thank you, Philipp. We have, let me see, 2 questions on Slido. The first one is, how can we scale JHAS for usage in multiple companies or institutions, universities? Well,
You need a governance for that. So like you need somebody who approves of your requests for courses at some point, right? So of course, each institution should run their own instance of this JupyterHub as a service, but you can do this, the code is published. And then you can reuse this infrastructure. Once you basically need like a Kubernetes cluster and have that set up, but you can then reuse it for different courses at the same institution. I would not recommend to use this across institutions because that's again a security risk.
All right. Second question. Did you consider running JupyterHub in Kubernetes environment?
Again?
Did you consider running JupyterHub in Kubernetes environment?
So you will have to ask the backend guys on that. This is being run as an orchestrated service, but it's not JupyterHub as you see. It's Jupyter, it's some sort of Jupyter lab. They have the reasons for this decision. I don't know exactly what they are. I'm sure they have considered it.
Okay. There's one more question from the audience on the Slido. Is there option to interact with students inside the JHAS?
No. Well, we have their home directories. Of course, you could mount those volumes and like edit some of the files, but this is not what you would typically do because you want to also give students control over their own data. So what you can do is you can allow them to pull from a GitLab repository or from some other source, pull new course materials, and of course they can edit their own service. But like you would typically give them feedback with nbgrader. So not directly. No, it's also not really possible if you have 200 students. Like you would need an appropriate number of TAs.
Okay, another question from the audience. JupyterHub spawner is the Docker spawner?
Hold on.
JupyterHub spawner is the Docker spawner?
Well, yeah, what spawns the Jupyter server, so to say, is it's a Docker container in the end. So you, as an instructor, you provide the Docker container, and that then is like spun up, basically, for each student who wants to log in.
All right. No more questions in Slido. Anyone would like to ask in person?
Thank you for the presentation. And my question is, what are the main benefits over Google Colab?
Over what?
Google Colab?
Google Forms.
No, Colab.
Google Colab. You have control over your own data. Like, Google Colab, I think, is run by Google, right? Or can you spin up your own Google Colab?
No, it's
No.
running
Yeah,
in the
that's why
cloud.
you don't want to do this, because you have GDPR issues. You have like all kinds of, like, you want to stay in control of your own data of your own students. Basically, you don't want to give this to some server in the US.
Okay, thank you. And other question, what is the best practice? Who is responsible for the user management?
The teacher, ideally. So this should be someone employed at the institution permanently. You don't want to give this to a TA. You don't want to burden the governance with that. But yeah, basically, whoever accepts submissions for the course, whoever is responsible for the module, they have to yeah, manage also their users.
All right, any other questions? One or two last questions, maybe?
It is possible to use it with GPUs?
Yeah, that's a point of contention. Like, it's not yet clear because you need to provide the GPU typically on the machine where, like, you cannot, yeah, well, you can split GPUs a little bit, but like not too much. We're working on it, so to say.
Anyone else? Also no one in Slido. I think we can wrap it up. Thank you very much, Philipp.
Thanks.